It answers our questions. It writes our essays. It conjures images from thin air. We speak, and this artificial intelligence seems to understand, to create, to think. But that's where the most profound misconception lies. Because AI doesn't understand language the way you or I do. It doesn't grasp nuance, irony, or the simple joy of a well-turned phrase. So, how does it cross the colossal chasm between our complex, messy human words and its world of pure, unyielding logic? The answer is both ingeniously simple and deceptively complex. It turns everything into numbers. The first step is simple: break it all down. Imagine an AI looking at a sentence. It doesn't see flowing prose. It sees a string of characters. Its initial task is to chop that string into manageable pieces called tokens. These can be whole words, parts of words, or even punctuation marks. Each unique token is then assigned a unique number. Think of it like a librarian meticulously assigning a distinct catalog number to every single word in every book ever written. A unique ID for apple, another for banana, a third for question mark. But simply giving each word a number only tells the AI what the word is, not what it means in relation to anything else. And that's where the real magic, or rather, the sophisticated mathematics, begins. To truly work with language, AI needs more than just a unique number for each word. It needs numbers that carry meaning. It needs to understand that king and queen are related, but king and banana are not. This is where word embeddings come in. Instead of a single number, each word is transformed into a long sequence of numbers, hundreds, even thousands of them. Think of these as coordinates in an impossibly vast, abstract space. Imagine a galaxy where every word is a star. The closer two stars are in this galaxy, the more similar their meaning, their context, or their relationship to other words. King and queen would be twinkling right next to each other. Man and woman close by. But banana? That star would be light years away. This isn't a random scatter. It's a meticulously crafted semantic universe. In this semantic universe, words aren't just isolated points. Their position, their distance from other points, and even the direction you travel between them encode intricate relationships. For instance, if you take the numerical vector for king, subtract the vector for man, and then add the vector for woman, you often arrive at a point remarkably close to the vector for queen. This isn't some mystical coincidence. It's how the AI learns and represents analogies, gender, tense, and countless other linguistic nuances purely through mathematics. Even seemingly identical words like apple, the fruit, and Apple, the tech company, would exist in entirely different regions of this numerical space. This incredible ability to capture context and meaning through proximity is the true engine behind AI's powerful text processing capabilities. This ability to translate words into meaningful numerical coordinates isn't just an abstract mathematical trick. It's the bedrock of modern generative AI. By understanding the numerical relationships between words, an AI can predict the most likely next word in a sentence, summarize vast amounts of text, translate languages with startling accuracy, or even generate entirely new content, from prose to poetry, code to complex reports. As researchers explored in Foundations of GenAI, this process allows AI to perform information generation and information synthesis on a scale unimaginable just a decade ago. It changes how we access knowledge, how we create, and fundamentally, how we interact with information itself. The black box is slowly opening, revealing a vast numerical engine. But does any of this numerical brilliance equate to true understanding? If an AI can generate a flawless essay, does it grasp the irony in a literary passage or the subtle emotion behind a poem? This is where the long-standing philosophical debate resurfaces, perhaps most famously articulated by John Searle's Chinese Room argument from 1980. Searle argued that if you put a person who speaks no Chinese inside a room, give them a giant rulebook, and feed them Chinese characters, they could, by following the rules, produce perfectly coherent Chinese responses. Yet, that person inside the room wouldn't understand a single word of Chinese. They are merely manipulating symbols. In the same vein, AI manipulates numbers with unparalleled sophistication. But does that manipulation, however brilliant, ever crossed the threshold into genuine comprehension or consciousness? The question remains an open, vital one. If AI learns its numerical language from human-generated text, from books, articles, websites, then it inevitably learns from our collective human biases. These biases, whether conscious or unconscious, become embedded in the very numerical relationships within the semantic galaxy. If historical data disproportionately associates certain professions with one gender, for instance, the AI's numerical embedding for doctor might inadvertently pull closer to man. As recent research, like the demystifies preprint, highlights, human cognitive biases, such as confirmation bias, can be amplified when interacting with AI systems that reflect these numerical predispositions. This isn't AI being inherently malicious. It's a mirror reflecting the imperfections in the data we feed it, scaling our human prejudices and making metacognitive AI literacy, the awareness of one's own thinking, more crucial than ever. The journey from human language to machine logic, from our nuanced words to AI's cold numbers, is an invisible bridge transforming our world. It empowers machines with capabilities previously confined to science fiction, but it also casts a long shadow, raising profound questions about understanding, bias, and our own responsibility. This isn't just a technical detail for engineers. It's a fundamental mechanism that underpins the intelligence we increasingly rely on. Understanding how AI converts words into numbers empowers us to move beyond the black box, to ask better questions, to demand transparency, and to critically engage with the tools we are building. The future of this powerful numerical language isn't predetermined. It's being written, byte by numerical byte, by all of us, right now.